Hello. All right, so this is a video to help you out with number 4. Now, in number 4, what we have is what's called a geometric sequence of numbers, and the sequence goes like this. So the n is the number of the term. So what I mean is that the first term of the sequence is going to be 729. Okay, so I'm going to make a table, and hopefully that'll help us pick apart the pattern of this sequence. The second term is going to be, what was it, 243? Okay, that's where the second term, that means that n equals 2. The third term was, what would that be, 81. The fourth term is going to be 27. And then the problem asks you, as most of you could do on your own, the problem asks you to find the fifth and sixth terms of the sequence. Well, you can see what's happening. The pattern is we are dividing by 3 every successive term. So 729 is 3 times larger than 243, which is 3 times larger than 81, which is 3 times larger than 27. So you could probably find these next two numbers by dividing by 3. Now, just about everybody could do that. Okay, so 27 divided by 3 is 9, and 9 divided by 3 is 3. Okay, so no big secret there. Now, here's where we're going to use, we're going to look for a pattern of these numbers. And I think a lot of people noticed, well, this is 3, this is 3 times 3, this is 3 times 3 times 3, and this is 3 to the 4th and 3 to the 5th. So we're going to write these as a power. So this is going to be 3 to the 6th, 3 to the 5th, 3 to the 4th, 3 to the 3rd, 3 squared, and 3 to the 1st. Okay, and question 4b asks you to express this pattern in terms of n. Okay. Well, I tell you what I'm going to do is, oops. What I'm going to do is I'm going to just think about why am I having such a hard time with this? I didn't do a very good job setting up this table, but let's just write here for a second the exponents. Well, the exponent when n is 1 is 6, the exponent here is 5, the exponent here is 4, 3, 2, 1. And I don't have a number over here, but let's say when n equals 0, that if we went back a step, you can imagine that the exponent here would be 3 to the 7th. All right. So it looks like as n is getting bigger, the exponent is getting smaller, and that is true. That's what's happening. And it starts when n is 0 at 7. And there's really, I can't remember if we've learned an easy way to model something like this. But if n is getting bigger and that makes the exponent get smaller, you could think of this as being 3 to the something, starts at 7, and it's getting smaller. So we're going to subtract n. So every time n goes up by 1, we're going to be counting down. This is going to start at 7. When n is 1, it's going to go down to 6. When n is 2, this will go down to 7 minus 2 is 5. So this is the expression we're looking for. And we could call this like an f of n, a function of n. Okay, it's an expression of n that allows us to find these numbers here. Okay, I hope you don't see this. Let's see here. Now, the next step, all right, so now we know that this is the expression, and this is going to help us solve this next equation. We want to know at what point in this sequence are we going to run into this number? 1 over 2,187. Timmy, what are you doing? You're freaking out over there. You're on video right now. All right, anyway, dog freak out. All right, so what we want to do here is let's just think about this number on the bottom. Okay, this number on the bottom is a power of 3. Well, 3 to the what, you might ask? Well, let's see. We know that 3 to the 6 is 729. What happens if I take 729 and I multiply by 3? Well, that's going to give me 27, carry the 2, this is an 8, and look at that. Oh my goodness. All right, so 3 to the 7th. This right here is equal to 1 over 3 to the 7th. Just delete this little bit here. And another way I can write that is by saying that this is 3, well, 1 over 3 to the 7th would be 3 to the negative 7th. That's the definition of negative exponents. All right, so let's take a look. I know that I get these numbers in the sequence by doing this formula right here. So let's go ahead and set up the formula. 3 to the 7 minus n, and this is going to be equal to 3 to the negative 7. Okay, well, I've got two powers that have the same base and their exponents, and they're equal, and their exponents have to be equal. So I can go ahead and say that 7 minus n is going to be equal to negative 7. And sure enough, if you solve this for n, you'll come up with the solution to this equation, or to this problem. This video was made on the fly without a whole lot of prep. So if you have questions after this, leave me a comment, send me a private message on Classroom, whatever you want to do. Okay, good luck to you.